Hello everyone, I'm Gauri Toshniwal. I'm representing Team Sarang to present our work on FinCausal 2025 shared task, contextual question answering for financial causality detection, combining extractive and generative models. Let's get started. So, first let's highlight the motivation. In financial texts like annual reports or earnings statements, the question, why did something happen, is extremely important. Understanding the cause effect link can influence major decisions like investment or risk management. So, financial texts are high stakes and misinterpretation can lead to wrong decisions. We have observed that purely extractive or purely generative approaches have specific drawbacks, and so our goal is to see if we can merge the precision of extractive methods with the flexibility of generative models for better, more robust results. Why combine extractive and generative models? So, papers like Choose Your QA Model Wisely highlight the differences between extractive and generative QA systems. Extractive models like RoBERTa are quite precise. They literally pick the substring from the text, so they rarely invent information. That's crucial in finance, where a single term can change the meaning. However, extractive models can fail if they can't confidently find exact matching substring. They are also less flexible in paraphrasing. On the other hand, generative models can produce well structured answers and can handle minor rewording, but they risk hallucinating, basically making up content. This is dangerous in a factual domain like finance. Hence, a two-stage approach, extract first, then refine, can combine the strengths of both. So, with this intuition, let's get into the methodology. So, our methodology evolved in three main stages. Started by testing zero shot and few shot prompting on large language models to see how far we could push them without training. Then we moved to fine tuning a domain specific QA model because FinCausal is quite specialized. And finally, we discovered that combining these approaches, a fine tuned extractive model plus a generative refinement stage, gave us the best performance. Let's get into the method. So, we started simple, just took large language models and tried zero shot and few shot prompting. We used models like Llama, Mistral, Gemma, and ran them on the development dataset. The measure of performance was primarily semantic answer similarity and exact match. So, we did see some improvement after we carefully refined the prompts, giving model more explicit instructions. But eventually we hit a plateau on our accuracy matrix where tweaking prompts didn't help much. We also experimented with dynamic few shot prompting where we picked up semantically similar examples for each test sample and a parent child correction setup where the child answers and the parent will correct the answer. But these methods made some minor improvements, but the additional complexity didn't translate into higher scores. Also, all these initial prompting techniques helped us pick up the best large language model, which is Gemma in our case. Next, we moved from prompting to fine tuning. We started with a standard RoBERTa-base with a question answering head, but the performance on the development set was fairly low. So, for trying this activity out, we first converted our FinCausal development set into a Scott like format where the answer had the start and the end positions, filtered out the answers which are not substrings of the given context, and finally used this converted development set and split it into 90-10 train val split. So the accuracy metrics 46% essays and 7% exact match is on the 10% validation split which we made. Next, we tried to move to a more specialized checkpoint, which is consciousAI question answering RoBERTa-base, which was already fine tuned on SquadX. So that gave us a noticeable boost. So the key observation was a QA focused checkpoint and some domain data cleaning that led to strong performance jump. Our final most successful system is a two-stage pipeline. So first we use the fine-tuned RoBERTa-base model to pinpoint the exact substring in the context. That solves the typical hallucination issue because it's strictly extractive. Then we apply generative enhancement step using Gemma-to-9b instruction tuned, which cleans up or refines the answer, removing stray punctuation or making sure the snippet is coherent with the question. Because we feed in the context and extracted snippet to Gemma, it is less likely to hallucinate new information. So this combined method gave us our highest score on the benchmark. The data processing for the first stage includes lowercasing, removing spaces, and converting to scored format for all the samples of which have the answer in the context. The other samples have been removed while training. Once trained, a post-processing has been applied which removes full stops or commas at the end. And once the LLM integration happens where it enhances the answer, again a post-processing step is applied to remove extra full stop or extra tokens present to get the final output. The prompt for enhancement step checks whether the answer is present in the context, and if not, then the LLM would generate the answer. So here are the performance comparison on development set. So the initial prompting was done basically on different varieties of Llama, Mistral and Gemma, and we can see that Gemma 2 9 billion instruction tune performs the best with the prompt and post-processing. Next, here are some major system submissions. So first is Gemma 2 9b with few shot and post-processing. That is our baseline 1. After which we tried dynamic few shot LLM, baseline 2. Then coming on to consciousAI RoBERTa-base, which is purely extractive, which gave 92% of SAS and 62% exact match. And we can see just by cleaning the development set, there is a 3 to 4% improvement in the baseline 4. Finally, the best performing system is baseline 4 plus generative refinement, which gave us 96% SAS and 70% of exact match. So now, in conclusion, here are 4 main takeaways. Data quality matters. So cleaning out of context answers and formatting inconsistencies had a huge impact on the performance. Second, fine-tuning for the target domain helps. Third, the hybrid approach, a synergy of extraction and generation, consistently beats single model solutions, preventing hallucination while improving readability. And finally, post-processing and verification. So small steps like removing leftover tokens or verifying the final answer remains faithful to the context can prevent trivial score drops. Thank you. That brings me to the end of our presentation.